Welcome you all to this new video session. Today, in this video, we are going to learn about the rate of growth of a function. What do we mean by growth of a function? Let us learn with the help of an example. Let us consider three different functions: f of n, g of n, and h of n. F of n is equal to n. G of n is equal to n square and h of n is equal to n cube. Though we are having three different functions, let us see how each of these functions behave when we put different values of n. When value of n is equal to 1, we get f of n equal to 1, g of n equal to 1 and h of n is also equal to 1, which means when the value of n equal to 1, all these functions grow equally. None of them is faster and none of them is slower. What about n equal to 2? When we substitute the value of n as 2 in each of these equations, we get the value of f of n as 2, the value of g of n as 4 and the value of h of n as 8. It clearly shows that compared to f of n, g of n grows faster. Whereas compared to g of n, h of n is again faster. When h of n and g of n are both compared with f of n, then f of n is slower than both g of n and h of n. To be more specific, compared to f of n, g of n grows twice as fast of that, whereas compared to f of n, h of n grows thrice as fast of that. In this way, when we compare the growth of a function, depending on the increasing values of n, which one is faster and which one is slower, this rate of growth is termed as growth of a function. From this, we can say that the function f of n is a linear function because the value of f of n is such a way that the power of n is always 1. But when we consider the equation for g of n is equated to n square, and in this, the highest power of n in the equation of g of n is 2. Since the power of n is 2, in g of n, it is a quadratic function. What about h of n? In h of n, the highest power of n is 3. So it is a cubic function. Whichever function is given to you, check out the highest power of n. If it is 1, the function is linear. If it is 2, the function is quadratic. And if the function is said to be cubic, then definitely the highest power of n will be 3. Proceeding to the next section. Let us move on to an important topic, asymptotic complexity. What do I mean by asymptotic? Yes, asymptotic means big in size. What is this complexity? Well, as we all know, when we measure the length, we can represent it in centimeters, meters, kilometers, etc. When we measure the weight, we can measure and represent them in different units like grams, kgs and all. Whatever we measure, we do represent them in different units, irrespective of whether they are weights or heights or distances. Similarly, when we measure the complexity of an algorithm, we have to represent it with different notations, and those complexity notations are known as asymptotic notations. What is this complexity? Complexity means degree of difficulty of solving a problem. So we know that what are complexities, how to represent the complexities, and now we are going to learn asymptotic complexity. That means complexity which is big in size. These complexities will be represented using different functions. like f of n, g of n and all. Let us consider a function f of n. Here, the value of f of n is written such a way that it is n square plus 100n plus log n plus 1000. Now in the given equation, when we substitute the value of n as 1, we get 1 plus 100 plus 0 plus 1000. It clearly shows that to get the exact value of f of n, I repeat, to get the exact value of f of n, we require the contributions of 4 terms, that is n square, 100n, log n and 1000. So the contribution of each of these terms when summed up will give you the exact value of f of n. Let us check out the contributions of each term when value of n is 1. The contribution of the first term is 1. Contribution of second term is 100. Contribution of the third term is 0 and the contribution of last term is 1000. Out of the contributions of all these terms, the highest contribution is put forth by the last term. That means, though each of the term had their own contributions, maximum contribution was given by the fourth term. Okay. What happens if value of n increases? Let us move on and check when value of n becomes 10. When in the same equation the value of n becomes 10, contributions of each term will be 100 plus 1000 plus log 10 plus 1000. Here, out of the contributions of each of the terms, highest contribution is done by the second and the fourth term. I am not saying that other terms do not have any contributions. Yes, they do have. All the terms have their own contributions, but when the individual contributions are taken into grant, second and the fourth term contributed more, whereas the first and the third terms have contributions which are negligible in value. Proceeding to the next section, let us move where the value of n is taken as 100. When in the same equation f of n becomes 100, we get the contributions of each term as 10,000 plus 10,000 plus log 100 plus 1000. Out of the contributions of 4 terms, we noticed that the first 2 terms contributed more, whereas the third and the fourth term have contributions, but they are comparatively very less. Let us take one more case. This time I am going to take the value of n as 1000. When n is 1000, the contributions are respectively 10 lakh plus 1 lakh plus log 100 plus 1000. So this time I noticed that only the first term contributed more compared to the other 3 terms. So in this way we can say that with increasing values of n, for any function f of n, with increasing values of n, the highest power of n, the term which is associated with highest power of n, will be the only term which contributes more. I repeat, for any function f of n, with the increasing values of n, we notice that the term which is associated with highest power of n will be the only term which is contributing more to the value of f of n than compared to the rest of the terms in the same function. So asymptotic complexity says if the highest contribution is made by the term which is associated with highest power of n, then consider only that term and ignore the rest of the term. This process of ignoring the lower order terms and accepting only the highest order term is known as asymptotic complexity. Let us move on to an example. Suppose I am having the value of f of n as 2n plus n square plus 5. There are 3 terms in this function and I noticed that in this function, out of the three terms, the term which is associated with highest power of n is this term, because here the power of n is 1, here the power of n is 2, and this is a constant term, so the power of n is 0, because 5 is equal to 5 into n raised to 0. So the power of n associated with each term is calculated. For the first term it is 1, for the second term it is 2, and for the last term it is 0. So it has been noticed that in this particular example the power of n is largest for the second term. As per the rule, only this term contributes more to the function and the remaining terms do not contribute much. Their contribution is very negligible. So let us remove the lower order terms and just consider the highest order term. So we can say that f of n is approximately equal to n square. Why I am not putting an equal to sign, and instead of equal to I have put an approximation sign? Just because to get an exact value of f of n I require the values of all the three terms. But since I have crossed over the lower order terms and I have taken only the highest order term, then the value which I am getting using just the highest order term will not be the exact value. It will be just an approximation. So instead of writing f of n equal to n square, I am writing f of n is approximately equal to n square. So this process of removing the lower order terms and only accepting the highest order term to get the value of a function is called asymptotic complexity. Moving on to one more example, we can say, suppose the function is g of n, and g of n is equal to n cube plus n square plus 1000. Sorry, it's not 1000, it is 100n. As shown, it has three terms. Power of n associated with each term is, here the power of n is 3, here the power of n is 2, here the power of n is 1. Out of the three terms, the highest power of n is associated with the first term. So, taking only the highest order term and ignoring the lower order terms, we get g of n is approximately equal to n cube. This method of approximation is called asymptotic complexity. Hope you got the concept. Keep watching the videos and support me. Please subscribe the channel if you are not yet subscribed, and don't forget to hit the bell icon and click the all options so that you may get the notifications whenever I put on a new video. Thank you. Bye-bye.